Welcome to your Finite Math 2.5 lesson on inverses and solving systems. So we're going to solve systems of equation using inverse matrices. So first we need a little background information. The matrix equivalent to a 1 is an identity matrix, and they only exist for square matrices where the number of rows equals the number of columns. So there is an identity matrix for every size of square matrix. So a 2 by 2 matrix has the identity matrix of 1, 0, 0, 1. You're going to have ones on the main diagonal, upper left to lower right, and then zeros everywhere else. So for a 3 by 3, you would have ones again on the main diagonal and then zeros everywhere else. And the reason it's the identity matrix is because if you multiply it by a matrix of the appropriate size, the same size, you get the other matrix back. It maintains the identity of whatever appropriate matrix that it multiplies. All right, now there is no such thing as division in working with matrices, and so the closest thing we have to it is multiplying by the equivalent of a reciprocal, and that would be an inverse matrix. And only some square matrices have inverses, and it is denoted a to the negative 1. It looks like negative 1 power, a with the superscript of negative 1, but it's read the inverse of a. And we know a and b are inverses to each other. If a times b equals I and b times a equals I, you end up with this identity matrix. Just like when you multiply a number by its reciprocal, you end up with 1. Those concepts are analogous. We are going to use the cast to find the inverse of a matrix, and then we're going to look at using the cast to find a product of matrices, and then we're going to combine all of that to be able to solve systems using inverse matrices in your calculator. All right, we're going to find the inverse of the 2 by 2 matrix 1, 3, negative 1, 2 using your calculator. So first thing you got to be able to do is put the matrix in your calculator. So you want to go to your scratch pad and you want to click on the template key. That's the key where you can pick fraction and all kinds of things. If you're doing cube root of 27, you can put that in on this key. When you worked with logarithms, you could use this key. Anyway, on here you've got a template for all kinds of matrices. You've got 2 by 2, here's a 1 by 2 and a 2 by 1, here's a 3 by 3. The 3 by 3 you can actually manipulate the number of rows and columns to create whatever you want. If you wanted to create a 5 by 20 matrix, you could do it there. At least in theory. I'm not sure it'll let you go up to that many rows or columns, but you get my point. You can change it. You can make a 2 by 3, 3 by 2. This 3 by 3 one is one you can use to make any size matrix you want. But since we want a 2 by 2, we can pick the 2 by 2 template and then enter the elements and arrow to the outside of the matrix. So at first you get the little 2 by 2 that has a bunch of blanks, and you just put in 1, 3, negative 1, 2, and you arrow out here to the side, and then you click the superscript key, the little rooftop key, and enter negative 1. Press enter, and you get your inverse matrix right there. So 2/5, negative 3/5, 1/5, 1/5. Okay, and if you're getting decimals there, what you can do is go to settings and change from approximate to exact. And that, make sure you set that as your default, and then that'll start getting you your values as fractions. All right, we want to use our calculator to find the inverse of the matrix A. So I want you to do that same process, except choose the 3 by 3 matrix and then see if you get the inverse. Okay, so you're going to pick the 3 by 3 matrix, you're going to put these elements in, you're going to arrow to the outside, you're going to pick the rooftop key, the superscript key, and then you're going to put in negative 1 and enter, and you should end up with 15, 4, negative 5, negative 12, negative 3, 4, negative 4, negative 1, 1. Okay, so sometimes you get fractions in your inverse matrix, sometimes you don't. Okay, let's just practice multiplying two matrices using your calculator. It's a beautiful thing. Last class period you had to multiply by hand, so let's put this in our calculator. So you're going to choose, because we've got a 2 by 3, and that's not one of the templates you can choose. So do the 3 by 3, but just tell it you want 2 rows and 3 columns, and it will let you create an appropriate matrix, one that is this size. So then enter the different elements, -2, -3, 7, 1, 5, 6. Now, you want to click on the outside or arrow to the outside of the matrix and click on the multiplication key, because sometimes the calculator's not sure what to do if you just put two matrices next to each other. You got to tell it to multiply just to be safe. All right, you're going to do the 3 by 3 matrix again, but change the number of columns to 1. So you'll tell it 3 by 1, and then enter the elements 1, 2, and 3. Come out here and press enter, and boom, it gives you 1329, and that is the product matrix. All right, now we're going to get to the main point of the lesson. We're going to be able to solve systems with matrices. We're going to use what we learned about inverses and multiplying matrices using your CAS calculator. All right, so we've got our linear system of equations like we had at the beginning of the chapter. The first thing we need to do is change this to a matrix equation. So what you're going to do is you're going to pull out, first of all, you need to make sure it's in standard form, where your x's are first and then your y's, your equals, and your constants, and we are. You're going to make a coefficient matrix. The first row will represent the first equation. The second row will represent the second equation. And the two columns in the coefficient matrix are going to be your x column and then your y column. Okay, so you're going to put the coefficient of x here, the coefficient of y there. Okay, and then you're going to come down to the second equation and go, okay, I've got a coefficient of 1 of x, so that goes in my first column, and then I'm going to put -1 right here because it's the coefficient of y. And then you're going to make a column matrix where you list the variables in order, so x, y. And here's the really cool thing. If we multiplied these two together, look at what you get. You get 2x plus 3y. That's the left-hand side of the first equation. Okay, let's do the second row times this column. We'd have 1x minus 1y. Well, that's the left-hand side of the second equation. And then you're going to have equals, and you're going to make yourself a little column matrix and just put your constants there. So 10, -5. Now, if we were solving a number, just a regular equation, and we had 5x equals 25, we would divide by 5. But remember, there's no division for matrices. So we're going to do something kind of equivalent to that. Remember, dividing is really the same thing as multiplying by the reciprocal, so we're going to multiply by the inverse. Okay, now we want to multiply by the inverse of the coefficient matrix, and we would do that on the left. So we have to multiply by the inverse of the coefficient matrix on the left on the other side of the equation, because remember, order matters. Okay, you're not going to have to show all that work. What you do need to show is that xy is going to equal your coefficient matrix to the -1 power, because that's like using its reciprocal, times 10 -5. You need to show this. That way, if you mess up putting something in your calculator, I know you know the correct procedure and I can give you partial credit. Also, it makes it easier to enter it into the calculator if you have exactly what you need here. Okay, so I want you to enter this into your calculator. Do a 2 by 2 matrix. Enter 2, 3, 1, -1. Go outside the matrix. Do the superscript key and do -1, and then do times. You can't see the times there, but do times, and then put in a little 2 by 1 column matrix and put in 10 -5. Press enter, and you should get -1, 4. So your solution is the ordered pair -1, 4. Super duper easy, fast. Just make sure you enter the correct thing into your calculator. All right. So example 5, here's a word problem. An electronics company produces transistors, resistors, and computer chips. So it produces 3 things, okay? Each transistor requires 3 units of copper, 1 unit of zinc, and 2 units of glass. Each resistor requires 3, 2, and 1 unit of the 3 materials, so 3 units of copper, 2 units of zinc, and 1 unit of glass. And each computer chip requires 2, 1, and 2 of these materials, so 2 units of copper, 1 unit of zinc, and 2 units of glass. How many of each product can be made with 110 units of copper, 410 units of zinc, and 490 units of glass? The first thing you have to ask yourself is, what am I being asked to find? I'm being asked to find how many of each product. So I'm going to let T equal the number of transistors, R equal the number of resistors, and C equal the number of computer chips, because those are my unknowns. Now you need to think, okay, what totals do I have? I've got the total amount of copper being used, the total amount of zinc being used, and the total amount of glass being used. So I'm going to have a copper equation, a zinc equation, and a glass equation because I've got the total amounts of each of those. So for my copper equation, I'm going to go through and figure out how much is used for each type of product. Well, I'm using 3 units of copper for every transistor, so I'm going to have 3 times T. And each resistor, I'm going to use 3 units of copper, so plus 3 times R. And then for each computer chip, I'm going to use 2 units of copper, so plus 2 times C equals 810. Okay, so that's my copper equation. Now I'm going to go through and do the same thing for zinc. I'm going to have 1 for each transistor, plus 2 for each resistor, plus 1 for each computer chip, and that's going to add up to be 410. Finally, I'll do the same thing for glass. I'm going to use 2 units of glass for every transistor, plus 1 unit of glass for every resistor, plus 2 units of glass for every computer chip, and that's going to equal 490. So I've got my 3 by 3 equation. Now we could do this by hand using algebra, but it's going to be so much easier if we solve this 3 by 3 system using matrices and inverse matrices in your calculator. So let's make a matrix equation. The first row is going to be my copper equation, the second row is my zinc equation, and the third row is my glass equation. And so I put my coefficients, so 3, 3, 2, and then 1, 2, 1, and then 2, 1, 2, and then I list my variables in a column matrix in order, so T, R, C. And again, if I multiply this together, I would come out with these expressions. I'd have 3T plus 3R plus 2C, and so on. That's why this works. And so it equals, and then we put our constants in another column matrix, 810, 410, 490. Okay, so I'm going to take this column matrix and I'm going to multiply on to the left of it by the inverse of my coefficient matrix. So I want to write that down. TRC, my variables, are going to equal the inverse of my coefficient matrix times my constant matrix. So you want to put that in your calculator and you're going to get 100, 110, 90. Now you have to ask yourself, what do these numbers mean? The first one is T, that's the number of transistors. The second one is R, the number of resistors. And C is the third one, so that's the number of computer chips. And is that what I'm being asked for? I'm asked for how many of each product, and that is, because those are my products. So 100 transistors, 110 resistors, and 90 computer chips. Okay guys, it's really important that you be able to do this with your calculator, so make sure you've worked through the examples with your calculator and you can do it, and then try those problems to try on your own. Thank you for taking great notes, and I will see you in class. I hope you have a super day.